Okay, so on to question number 2 here. What is we're going to answer some questions about some IP addresses. So hopefully you're good on that math. First question, part A, what is the network mask in CIDR notation? So first we need to sort of read the packet for the IP config format up here and see that mask is located right there. So that's 255.255.240.0. You should be using your calculator for this and converting each of these numbers to binary, making sure that you're giving 8 digits for each if it happens to be too small to fit into 8 digits. But these should all actually fit into 8 digits except for the 0 part. And so we're going to translate this to binary first, and then that's going to tell us what the CIDR notation is. So 255 is going to be all ones. Dot all ones, and then 240 we need to convert to binary, and so we would do that by basically saying, either on our calculator or here I'm just going to do it by listing off the powers of 2 from 128 down to 1, and this is going to be the digits that we have, and we'll see that 128 plus 64 plus 32 plus 16 adds up to 240, and then we're missing 15 from it to get to 255. So we have 11110000, and then the 0 part is all zeros. So this is what a mask in CIDR notation should look like. I think I gave one extra 0 there, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, that one shouldn't be there. This is what a CIDR notation mask should look like, which is all ones followed by all zeros. And then the slash notation that we want is we're going to count the number of ones. So that's 8 plus 4 is going to be /20 would be our CIDR notation for that subnet mask. So that was a lot for 2 points there. Hopefully you can do that a little faster given the tricks of like knowing that 255 is all ones. So really you just have to look at the 240 there and figure out how many ones that is. So then what is a network ID? First address for the network. So here we're going to take the IP address that we're given, and that's this 192.168.65.110. And we're going to line that up with the network mask. And here I'm going to use a trick because the way we find this is we're going to apply the AND operation. And so if we do 1 and X, really X means here anything, or 0 and X, 1 with X with the AND operation is just going to be X. If X is 1, 1 and 1 is 1. If X is 0, 1 and 0 is 0. Right, so it depends on the value of X. If we whatever that value was, if we're ANDing something with ones. If we're ANDing something with zeros, ANDing something with a 0 is always zeros. So if we look at how this sort of lines up, no matter what we convert 192 in binary, it's lined up with all ones, right? So we're going to AND it with ones, which means that we're ANDing a 1 with an X, which means we get X. So when we apply that, we know that our network ID is going to start with 192.168 because those are ANDed with all ones. We know it's going to finish with zeros because that's ANDed with all zeros, right? And 0 ANDed with anything is going to become 0. So we're basically going to keep the first 2 because those are lined up with all ones in the mask, and we're going to get rid of the last one because it's lined up with all zeros. So the only thing I actually have to do any work for is what is 65 in binary and what does that line up with? So again, use your calculator for this, but I'll do it this way. It doesn't have 128. It does have a 64. 64 leaves us with 1 left. So when we sort of do the AND operation here, we're going to end up sort of going to skip over the digit, right? My result's going to come down here. So 0, 1, 0, 0, 0, 0, 0, 0. And that's my third digit. And if we convert that back, that's going to be 64. So that's my IP or my network ID there is .64.0. Okay. So then what is the first IP address assignable to a host on the network? First IP address is network ID plus 1. So we're just going to take this value and we're going to do 192.168.64.1. That's it. What is the broadcast address? Last IP address of the network. This one we have to do a little bit more work. We have to think a little bit about what this notation means. And what that means is we've got to split down the mask. And when we assign IP addresses, we're basically going to assign new values to all of those digits there. And that's how we're going to generate IP addresses. So we're going to have 4 whatever 0 or 1s that we want here, and we're going to have 8 whatever we want here. And the trick is that in the broadcast, we're going to assign all of those to 1s. And so we're going to assign all those X's to 1s in the broadcast address, and that's what we sort of have to figure out here. So we're starting with this address, and we're going to add these numbers to the individual digits. So this 1111 here is 15. So we're going to end up doing 192.168.64.0 plus nothing added here, 15 added to that digit. And then this is 255, so .255. We're just going to do the individual digit math, and we're going to end up with 192.168. Not 64, but now we're going to have .79 because 64 plus 15, and then .255 is our broadcast address. So again, that's really just we're keeping these bits the same in the network ID, and we're changing those bits to all 1s, and that's effectively the same as adding all 1s value in decimal here and all 1s value in decimal to that last digit. Last IP address is broadcast -1. So we just take our previous answer, 192.168.79.254. So we just subtract 1 from that. Determine the maximum number of devices that can be connected to this network. This is always going to be 2 to the 32 minus n minus 2, where we have the n is the number we used for the mask, that /n there. And so we're going to have 2 to the 32 minus 20 minus 2, and that minus 2 is for the network ID in the broadcast. And so this is 2 to the 12 minus 2, which should be 4,094 devices we can have on this network. And then the IPv4 address in the diagram is public or private. This is just a knowledge check here. Things that are private are 10.0.0.0/8, 172.16.0.0/16, and then 192.168.0.0/16 as well. So this is a private. Check these in your notes on that. I'm not 100% sure about that. This value here, but these are the private address range because it is in the 192.168 variant of this. So that's it for question number 2. That was a lot. Again, do some practice with this type of math and making sure you can do these AND operations.